Hello and welcome back to our discussion of the respiratory system. In this video, we are going to be talking about anatomic dead space and alveolar ventilation. So I want to start by introducing you to this concept of total pulmonary ventilation, which is the volume of air moved into and out of the lungs per minute. So conceptually, this is very similar to cardiac output, which told us how much blood was coming out of our heart each minute, okay? Except it applies to the lungs. So taking a look at this again, it's the volume of air moving into and out of the lungs per minute. Let's take a moment now and see if you can think of how we can express this mathematically, okay? Okay, so hopefully you figured out that you can figure out the total pulmonary ventilation by multiplying your ventilation rate times your tidal volume. Okay, so let's take a look at an example. You've seen this figure before. What we're going to do is take this figure and calculate the total pulmonary ventilation in this example. Oh, also, I forgot to mention total pulmonary ventilation is also known as minute ventilation. So go ahead, hit pause, calculate that total pulmonary ventilation.
Okay, so let's calculate total pulmonary ventilation in this example. So again, total pulmonary ventilation is going to be equal to ventilation rate times tidal volume. We know that our tidal volume is 500 milliliters. To figure out our ventilation rate, we can look here at this time scale, and we can see that one breath is going to take us 4 seconds. Okay, so what we're going to do is we're going to, for a ventilation rate, we're going to say one breath per 4 seconds. Okay, we're going to multiply that by our tidal volume, which is 500 milliliters per breath. Okay, and then we're going to just convert from seconds to minutes. Okay, so I'm just going to put an equal sign here. Okay, and then that comes out to 7,500 milliliters per minute, or 7.5 liters per minute.
Okay, so we just went over total pulmonary ventilation. You were able to calculate it, hopefully. I want to also let you know that these numbers that we have used are pretty typical values. So for the ventilation rate and the tidal volume, those are pretty typical values for a person at rest. However, now that you know how to calculate total pulmonary ventilation, I'm going to throw a wrench in things and tell you that total pulmonary ventilation is actually not the best measure of respiration. And this is why. Okay, so the reason that total pulmonary ventilation is not the best measure of respiration is that when we breathe, we trap air in our airways. Okay, and that air that gets trapped in our airways does not get to participate in gas exchange. Therefore, even though we take in 500 milliliters per breath, we're actually only able to make use of a fraction of that total volume that comes into our system, okay? So just to further illustrate this example or illustrate this concept, we're gonna walk through this example here, okay? Before we walk through it, I'm gonna give you some pieces of information to orient you to this figure, okay? So what is going on here is this big blue bubble here is the lungs, okay? This little purple box right here is the anatomic dead space. Purple indicates fresh air with a high partial pressure of oxygen, and blue indicates stale air with a low partial pressure of oxygen, right? So let's get started. Okay, so starting at the top, we're going to start with the end of an inspiration. Okay, when we have finished inspiring, sorry, the air that we have inspired, some of that fresh air makes it to our lungs. Okay, and that air participates immediately in gas exchange and it becomes stale air. Hence, the fact that this whole bubble, representing the lungs, is blue. Okay. We also have fresh air that comes into our airways, and that air does not participate in gas exchange. Therefore, it remains fresh air. So that's why it's shown as purple here. Okay. Moving on to our next step. Oh, sorry. Also, just want to mention most of the air in the lungs is stale, right? Because we have all this residual volume and our expiratory reserve volume, all of that has participated in gas exchange. Okay, moving on to our next step, let's see what happens when we exhale. Okay, so when we exhale, we're going to assume a normal tidal volume of 500 milliliters. Look at what happens here. The first air that comes out, that gets exhaled, is that air that was trapped in our airways up here. And this is air that never participated in gas exchange. So this is fresh air that we were not able to utilize, and we're just breathing it out of our airways, okay? And then we have 350 milliliters that came from our lungs that was able to participate in gas exchange, and that is being breathed out. So of our 500 milliliters that we breathe out, only 350 milliliters of it was air that participated in gas exchange. Okay. Moving on. Looking here at the end of the expiration, we end up with stale air in our airways, right? We're pushing air out of our lungs. That is stale air. It moves up from the lungs into the airways. So the air in our airways is stale air with a low oxygen content. And then finally, looking here, let's imagine what happens when we breathe in after that. When we breathe in, the first 150 milliliters of what we breathe in is going to be that stale air that was already in the airways. Okay, so this is air that has already participated in gas exchange. So we're breathing that in, but we're not going to be able to make any use of it because it's already used, right? We already took advantage of the oxygen that was in that air. And then it's only the next 350 milliliters of our breath, okay, that is going to provide us with fresh air that can oxygenate our blood, okay? Finally, I just want to say that we end up at the end of inspiration, we end up again with that 150 milliliters of fresh air in our airways. Okay, so sort of the upshot of this whole figure right here is that whenever we breathe in and out, even though we're breathing in and out about 500 milliliters, we're actually only able to make use of about 350 milliliters of that breath. Only that 350 milliliters is taking place in gas exchange. Okay, the rest is just getting trapped in our airways and it's not being utilized.